All right, only 3 problems. Yeah. That's what I'm talking about. That means we're getting better. Okay, number 5. Wait a minute, wait a doggone minute. You're telling me everybody here did number 4 correctly? I'm gonna walk around with my grade book right now. Because that's a, if you don't, if you didn't do number 4, I highly suggest you write it on the board now. Just sit down, I just do it. See, that's why you don't do your homework. How do you know what the important problems are? This is supposed to help your grade, but then I don't know, man. No. I don't know. Okay, so 1 plus negative x squared. See how I write b as negative to the negative 3. It says show the first 5 terms and then find the 1,000th term, which means 1,000th or the 100th? 100. That means there's going to be a pattern. Okay, go. A to the n plus n. The power of a goes down by 1. The power of b goes up by 1. N minus 1 over 2 factorial. The power of a goes down by 1. The power of b goes up by 1. Have we memorized the binomial theorem yet? Or I just don't know with you guys. 3 factorial. The power of a goes down by 1. The power of b goes up by 1. And the pattern is like, it's not like a difficult pattern. Right? What? Look, if you got 4 numbers on the, if you got 4 factorial on the bottom, you gotta have 4 things on the top. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem. Okay, now simplify each one. 1 plus 3x squared. Now I can do this, you guys gotta be able to do it. Now, if you don't, like I kind of graded kind of easy on this quiz, but on the test, some of you, like this thing, you're putting it there. You're like shifting it over 1. Come on, the first term is simply that to that power. There's no coefficient there, right? Okay, the next term, that's going to be 6x to the 4. And the 3's cancel out, so just 10x to the 6 plus, and then 3, 4 cancel out, so 15x to the 8. There you go, that's the first 5 terms. Now find the 100 terms because there's a pattern. You guys see the pattern? Okay, the pattern is it's going to be something x to the something. Fill in the boxes. Okay, let's look at the powers of x first of all. Look at the first term. Isn't the first term like x to the 0? Is there a pattern to these numbers? 0, 2, 4, 6, 8. It's a sequence. What kind of sequence is this? Like if somebody were to ask you, find the 100th term, could you? I hope so. This is like algebra 2 here. What kind of sequence is that when you keep adding the same number every time? It's called an arithmetic sequence. You have to know this on the PSAT. Isn't the PSAT very soon? This is on the cheat sheet. If you want a cheat sheet, email me. I'll send you one. But come on, this is basic. Okay, does this formula look familiar? This is the formula for an arithmetic sequence. Okay, so for this one, what's the first term? A1 is the first term. 0 plus n minus 1d. D is the common difference, the number you keep adding every time. 2. Simplify, 2n minus 2. This is the formula for this sequence. If you plug in 1, you get the first term. You plug in 2, you get the second term. You plug in 3, you get the third term, and so forth, right? Okay, so if you want to find the 100th term, what do? You plug in 100, and you get 198. Now, probably a lot of you could just figure it out, right? Just by looking at the numbers. But then, what if it's not as nice, the pattern, on Tuesday? Then you want something to rely on. See, some of you can do it when it's easy, but then what happens when it gets kicked up a notch? Okay, now look at these numbers in the front. 1, 3, 6, 10, 15. 1, 3, 6, 10, 15. Is this an arithmetic sequence? No, because you don't add the same number every time. But these are famous numbers that you should know. I already talked to your pre-algebra teachers and they told me they taught you this. What special numbers are these numbers here? These are the blank numbers. Thank you. These are the triangular numbers. How do you know that?
I don't know. I guess. Also, it's funny.
Okay, these are the triangle. You know why they call these the triangular numbers? Does that sound familiar from 7th grade? Why do they call these the triangular numbers? Because they make triangles. Look, 1, and then 3. See how it makes a triangle? And then you add 3 more. And then you add 4. Okay, bowling right there, you add 5. It makes triangles. Just like the square numbers. You know why they call 1, 4, 9, 16, 25 the square numbers? Because they make squares. 1, 9, 16. And remember in intermediate, you guys learned, and then, well, there must be pentagonal numbers and hexagonal numbers. Okay, anyway, does anybody remember the formula for the triangular numbers? Yanamini?
It's an arithmetic sequence.
No, it's not that. You don't add the same thing every time. Okay, here, look, you break it down. You break it down. Like, is it 1 times 2 over 2? Is it 3, 2 times 3 over 2? Isn't 6, 3 times 4 over 2? We cannot even do that in our head. Number 10, isn't that 4 times 5 over 2? 5 times 6 over 2? I see a pattern! Now what's that pattern? How do you write the pattern? Even with this, n times n plus 1 over 2. That's the formula for the triangular numbers. We learned that in intermediate school. I just was talking to Mrs. Wada and she said, yeah, they went over it several times. Anyway, I'm going to tell you right now, these numbers come up in this course and in PC Calculus many times. So if you're going to forget this, you're in a heap of trouble. These are famous numbers. Okay, anyway, this is the formula for the triangular number. So how do you find the 100th one? Plug in 100. So if you plug in 100, you get 100 times 101 all over 2. 2 goes into 100. I know why the thing didn't record. I think I didn't press the record button in period 3. That's why. I just remembered now. I hope I pressed the record button now. Anyway, 5 times 101 is 505, but then you gotta add a 0. So 5050, there you go. That's a pattern. I can't believe we don't know the triangular numbers. You guys know the square numbers, right? I don't know. 1, 4, 2 squared, 3 squared, 4 squared, 5 squared. Just like the cube numbers. You know why they call them cube numbers? Because they form cubes. I don't know, maybe you never made that connection before. I don't know. And why do they call them pentagonal and hexagonal numbers? Because they form pentagons and hexagons. Okay, next. I'm glad we went over that because otherwise some of you, one problem on the test gone already. Oh, so are you saying the triangular numbers are on the test? Maybe. Number 5. No! 1 plus x to the 1/3. Now, if you've been doing your homework, you know the pattern already. Can we go right to the 6th term already? Or do I have to write out all the way to the 6th term? Can we go right to the 6th term? Okay. So tell me, in the 6th term, what's in the denominator? 4 factorial, 5 factorial, 6 factorial, 7 factorial? 5 factorial, right? Well, for those of you who've been doing homework, right? And then what? Well, Then you're gonna have 5 numbers on the top then, right? What are the 5 numbers? Yeah, you start with this. So 1/3, and then you keep subtracting 1. And some people, they have problems subtracting 1. -2/3, -5/3, -8/3, -11/3. The power of A goes down by 1, the power of B goes up by 1. Did anybody figure it out yet, the pattern? That number is the same as the number up there. And the 2 things gotta add up to that. -14/3. Anyway, look. Doink, 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 doink. That you subtract 1, that would be the next one.
We're missing word.
No, I'm not missing it. And then you simplify it. You simplify it. Okay, here's the problem. You know what the period 3 said? I have hard problems with fractions. Well, I can't help you with that. You're supposed to know how to deal with fractions by now. But look at how many things cancel out. It's not that bad. Okay, you guys just take it from there. You guys. Okay, number 7B. Ooh, good choice. Doesn't this look like the one we did yesterday? This is exactly what I'm talking about, period 4, if that's really who you are. Yesterday, didn't we do this? So I change it to a minus, all hell breaks loose. And I'm going to tell you right now, this problem is on the test. In fact, this is the second to the last problem, I think. Not going to be lines, though. These are just lines. Not going to have lines here. Okay, so what do? It's not going to have the hint. You're not going to have the hint on the test on Tuesday. What are you going to do? What did we learn yesterday?
Quadrant.
Go by quadrants. Okay, in the first quadrant, what's the equation? Dot.
X minus y is 1.
Okay, do we know how to graph a line? Yes, except on Tuesday you got to ask yourself, do I know how to graph a parabola? But now since I told you that, do I know how to graph a cubit? But now since I told you that, now do I know how to graph a quartet? Now since I told you that, go back to the line. We did that last chapter. But it's over the last chapter. No, it's not. We keep using it throughout the whole year. Okay, the fastest way to graph a line is to plot the x-intercept is. X-intercept is. Do I have to really do this? 1. Y-intercept, -1. So here is the line. Now you don't have to graph it like that, but you only graph it in the first quadrant. So what's the part of the line that's in the first quadrant? Just that part right there. You just go by quadrants. Okay, second quadrant, what's the equation? Chineng.
Negative x minus y equals 1.
Oh, see, you guys know how to do it. The x-intercept is -1. The y-intercept is -1. So but you only graph it in the second quadrant. Now this is what period 3 had the gall to say. Oh, I know what the graph is going to look like already. Because they think it's just going to, don't. Well, maybe in this problem it might, but I have tricks up my sleeve. Just believe me. Okay, next, third quadrant, what's the equation? Chen?
Negative x plus y equals 1.
Yeah, you guys know how to do this. So x-intercept is -1, y-intercept +1, the line looks like this. But you graph it only in the third quadrant, so it's that right there. And you can probably just guess what that's going to be, right? Unless it's not. Okay, fourth quadrant, what's the equation, Hori?
X plus y equals 1.
So the x-intercept is 1 and the y-intercept is 1. So it's like this. But you only graph it in the fourth quadrant. Booga! So just be prepared. So if you want to get it right, don't assume anything. Just go through all 4 quadrants on Tuesday and nobody will get hurt. If you assume some kind of symmetry or something, then that's what's going to put you in trouble right there. And then number 8, how many people got number 8? Because I gave you a hint. 10? Okay, well, that means period 3 is smarter than you. Because one person got it.
We don't know Max is.
Who got it?
Max, come on, give me a break. Okay, this problem is on the test. Okay, this is the last. This is number 10. This is the last problem on the test. Except you know it's going to be kicked up a notch. So make sure you understand this. 9 to the 23rd power. Find the last 3 digits. What if I let you use a calculator? Could you do it? Some of period 3 says, oh yeah, just punch it in on the calculator and look at the last 3 digits. No, moose breath. Because this number is so big, it doesn't show you the last 3 digits. It's scientific notation. You know what I'm talking about? So even if I let you use a unless you have a TI-89. Anybody have a TI-89? TI-89 shows 200 digits. That's all. Anyway, you're not allowed. You are not allowed to do this to use a calculator on the test. So how do you do it? What's the hint I gave? I'm not going to give you the hint either. Change it to 10 minus 1 to the 23rd power. Why?
Same thing.
Yeah, I know it's the same, but why not like 8 plus 1? Why 10 minus 1? Why not? Or 7 plus 2? Or 12 minus 3? Why 10 minus 1?
What's this number?
Because what?
There's 23 zeros.
Exactly, because when you raise 10 to the powers, you get a lot of zeros, that's why. That's why 10. So remember that. So what if, like, if you look at binabsineq4, I think it's 101. 101 to the something power, so how do you write that? 100 plus 1. You want to use 10, 100,000, and so forth. Now, since I told you that, it would be 10,000. Okay, so if I were to expand this, how many terms would there be? 24. Should I write out all 24? No, because some of them are not going to even contribute to the last 3 digits because they have so many zeros. You know what I'm talking about? Like, for example, what's the first term going to be? 23 choose 0. A to the 23rd, B to the 0. So basically this number is a 1 followed by 23 zeros. Is that going to help me find the last 3 digits? No. What's the second term going to be? 23 choose 1, 10 to the 22, negative 1 to the 22, right? 22, 1. This number ends in 22 zeros. Is that going to help me find the last 3 digits? No, so what do I want to look at? You look at the ending part of it. Because that's going to contribute to the last 3 digits. Because those numbers are smaller. Okay, so if we work all the way to the end, this is just like the quiz, right? Find the last 4 digits. What's the last term going to be? 23, choose 23. A to the something, B to the something. That is the same thing as that, and the 2 powers got to add up to 23, right? Okay, what's the term before this going to be? 23, choose 22, 10 to the something, negative 1 to the something, but that number is the same as that, and they all got to add up to 23. Okay, what about the term before this? 23, choose 21, 10 to the second, negative 1 to the 21. This number ends in 2 zeros. See? 10 to the second power. When you multiply by 100, it ends in 2 zeros. So do I even need this next one over here? No, you don't need this because it's going to be 10 to the third. 10 to the third is 1,000. If you multiply something by 1,000, the last 3 digits are going to be 0, 0, 0. It's not going to help you find the last 3 digits, right? You know what I'm talking about? I only want to know the last 3 digits. However, on the test, if I ask you for the last 4 digits, then you're going to need this one. Okay, let's just work backwards. Okay, what's this one? 23 choose 23 is the same thing as 23 choose 0, which is 1 times 1 times negative 1. We cannot multiply 3 ones together. Negative 1. Okay, 23 choose 22 is the same thing as 23 choose 1, which is 23 times 10 times 1. We cannot multiply a double-digit number by 10. 230. Okay, what's the term before this going to be? 23 choose 21 is the same thing as 23 choose 2. Now that one we might have to go on the side and do it. 2 times 1 under 23 times 22. 2 goes into that 11 times. 230 plus 23. 253. But then when you times it by 100, you get 2 zeros, and then that's negative 1. So, it's like that. So that's the last 3 terms. Now, the term right before this one is something, but it ends with 3 zeros, right? Because it's going to be 10 to the third, that's why, right? But you don't really need to know, because we're only looking at the last 3 digits. Okay, we got it now. So if you have a number that ends in 000, and you subtract a number that ends in 300, what are the last 3 digits going to be? 700, right? And then you're going to add 230 to it. So you add 230 to it, you get 930. This is just the last 3 digits. And then you subtract 1. So what is that? 929. There you go. Okay, so this problem is on the test. Okay, we've got about 15 minutes left. Let's take a look at a couple problems on binabsineq4 then. Now you're only handing in 1, 2, 3, and 4 now. That's all we have time for. And then next chapter is even, well, next chapter we're only going to have 3 lessons. But then we have to take the test the following Tuesday because it's reserved for that. So that means you might not even have a practice test for the next test. You're going to have to clutch up. Well, come on, last year you didn't have practice test. You go to BC Calculus, there's no practice test. You don't need a practice test. You learned all the material. Okay, let's practice graphing when it's not a line. Like, okay, are you looking at binabsineq4? Wait. Oh, no, never mind. Number 3a. Absolute value of y is equal to x minus absolute value of x. See how you get x squared there? That will be lines in there. Okay, but you do the same thing. Just don't do anything different. So no matter how strange it looks, it might look a little bit strange. You do the same thing. You go by quadrants. Okay, what's the equation in the first quadrant going to be? Lee?
Y equals x squared minus x.
See, you guys can do it. Okay, now how do you graph that? It's a parabola.
Intercept.
Okay, factor it. So the x-intercepts are 0 and 1. And it opens upwards, so it's like that, right? But you only graph it in the first quadrant. What's the part of the graph in the first quadrant? Just this part right here. There you go. This is easy, Mr. Park. Yeah, it is until you get until there's a twist in it. Yeah. Okay, what's the equation in the second quadrant? Ichimura.
Y equals x squared plus x.
See, you got it. Factor it. The x-intercepts are 0 and negative 1. So it's like over here. And it opens up because the leading coefficient is positive. But you just graph it in the second quadrant, which is just this part right here. What's the equation in the third quadrant? Yanomini?
Negative y is equal to x squared.
Okay. Multiply both sides by negative 1 because you just want y equal, right? Factor out a negative x and you get x plus 1. So the x-intercepts are 0 and negative 1, except it's opening down. So they open down like that. So what's the part of the graph that's in the third quadrant? Just that part that's over there, right? And you can probably guess what the last one is, yeah? But then you might be wrong. Yeah. Okay, so that's why don't take anything for granted, just do it. In the fourth quadrant, what? What's the equation in the fourth quadrant? Kawato.
Negative y equals x squared minus x.
Yep. Multiply both sides by -1. Factor out a negative sign, negative x rather, and you get x minus 1. So the x-intercepts are 0 and 1, except it's opening down. And then, waka! There you go. Oh, so Mr. Park, the graph always gonna be symmetric like this. Maybe, maybe not. And then look at number 6. Well, how would you do number 6? You change the 101. See, there's no hint. Change the 101 to 100 plus 1. And then last 6 digits. But then you have 100, right? You know what I'm talking about? So it's not that bad. You don't have to look at that many terms. And look at the problems from number 1. That's all the problems we've done before, right? So I don't think there'll be any surprises. I don't think any test has any surprises anymore. So, are we done then? No last questions? Okay, then we're done. Okay, so if you have any last minute adjustments you want to make, come Tuesday morning.
Yes, you did.
Mm-hmm.
I did the rest of it.